Let's look at this problem, 4 minus 1 over x squared, all of that over 2 minus 1 over x. When you deal with complex fractions, which are fractions divided by fractions, you need to make sure that the numerator is one fraction and the denominator is another fraction before you can actually simplify it further. In the numerator, we have a whole number and a fraction, and the fraction is x squared. We need this whole number 4 to be a fraction with a denominator of x squared. So we're going to rewrite the numerator as 4 over 1 minus 1 over x squared and 2 over 1 minus 1 over x. The reason I left space there is we need to multiply the 4 over 1 times x squared over x squared so that it can have the same denominator as 1 over x squared. In the denominator, we need to multiply 2 over 1 by x over x for the same reason. If you have questions about this, you need to look up the links on fractions that I posted in Ziegler links. All right, now that we have that, go back to my blue ink, wherever it is. We can rewrite this by multiplying the fractions together. We get 4x squared over x squared minus 1 over x squared. So we now have the same denominator. And in the denominator, we have 2x over x minus 1 over x. Again, the same denominator. So when we have the same denominator, we can keep the denominator the same and combine the numerators 4x squared minus 1. In the denominator, we keep the denominator the same and combine the numerators 2x minus 1. And now we have a fraction over a fraction. I'm going to go over to the right to finish the problem. With a fraction over the fraction, our next step is to say, okay, that's a division problem. It's 4x squared minus 1 over x squared divided by its denominator, 2x minus 1 over x, because that's what a fraction is. It's a division problem. So you rewrite it long ways, and then you use KFC to change your division problem into a multiplication problem. You keep the first term, you flip the second term, and then division changes to multiplication. Keep, flip, change. All right, so now what do we do with this? Well, let's see if we can factor this numerator. 4x squared looks like a perfect square, and it is. 2x, all of that squared, becomes 4x squared. But we need a perfect square here if we're going to factor it, and 1 is the same thing as 1 squared. So we can rewrite this as 2x squared minus 1 squared, and that gives us a difference of squares. So let's change that. A difference of squares is, I should write it like this, is you write the first root, 2x, add the second root, and then you subtract them. So now we've factored this numerator. So I'm going to get rid of that equal sign there to show that we're doing a little extra work there. And now we can rewrite our numerator up here. Instead of 4x squared minus 1, we have that. Now when we multiply fractions, we multiply the numerators. So we multiply that times x, the numerator of the second fraction, and we multiply denominators. Okay, now everything is multiplied together. We have a binomial, a monomial on top, a monomial, and a binomial on the bottom. Now we can cancel factors. Notice that we cannot cancel this 2x and this 2x. They are all one binomial factor. The 2x itself is not a factor by itself. It is a term that is subtracting 1 from it. But the binomials that are identical, we can cancel. Also, this x and this x squared, one of the x's down here go away, and we're left with x in our denominator. So our final answer is 2x plus 1 over x. And I recommend you circle what's left so you don't leave anything out. So let's write that in here. 2x plus 1 over x. Our next problem has a difference of fractions in the numerator and then one fraction in the denominator. So the denominator is ready, but we have 1/5 minus 1 over a in the numerator. So we need to be able to combine those two fractions into one fraction. And to do that, we need a common denominator, which in this case is going to be 5a. So we rewrite 1/5 times times a over a minus 1 over a times 5 over 5, and that gives us 5a in the denominator. So in this denominator we had a 5, but we need an a to get a 5a. In this one we had an a, but we need a 5 to get an a5, and that's why we multiplied by a over a in the first case and 5 over 5 in the second case. And here we have 5 minus a over 5. So now we have two fractions to multiply. We have a over 5a. I'm going to go ahead and combine them. Minus 5. All of that. When you have the same denominator, you keep the denominator and you combine the numerators. Let me put this a little bit smaller. Okay, so we have a minus 5 over 5a, and then 5 minus a over 5. Okay, so now we have, let me do this. We have a fraction over a fraction, so we rewrite it long ways. A minus 5 over 5a, and then KFC is we keep the first, we flip the second, and we change division to multiplication. So the step I didn't actually write is rewriting this horizontally. It's a division problem. And so we keep the first, flip the second, and change division to multiplication. Okay, now we have binomial, binomial, and then monomial and monomial. So what cancels? Because when you're multiplying, you're just going to multiply the numerators over the denominators. And what is 5 minus a? If you remember, it equals negative of its opposite, a minus 5. So let's write a negative here. That's how we do that. And then we can start canceling. The 5's cancel. We still have this a, and the a minus 5's cancel. Okay. Be sure that you write a 1 in the numerator if everything cancels, and in the denominator all you have left is the a. In our next problem we have x over 5y cubed plus 3 over 10y, and then on the bottom we have 3 over 10y plus x over 5y cubed. It's a very easy problem if you know that when you're adding two things you can add them in either order. So this is identical. The numerator is identical to the denominator if we rewrite the denominator by switching around the terms. Okay, so now if you look, we have this binomial and this binomial, and they're identical, so we can cancel them, and that equals 1, and that's all there is to that problem. Okay, let's look at the next problem. We have 3/8 plus 4/5 equals x over 20. We have an 8 and a 5 and a 20. And we need to know a number that all three of those go into. So we're going to write multiples. 8, 16, 24, 8 times 4 is 32, 8 times 5 is 40. We'll stop there unless we need to go on. 5 times 1 is 5, 5 times 2 is 10, 15, 20, 25, 30, 35, and 40. And then for 20, we have 20 and 40. So what we want to do is circle the first number that all three have in common, and here it's 40, 40, and 40. So our common denominator needs to be 40. Our least common denominator equals 40. So now all we have to do is multiply every fraction by 40. But when you multiply a fraction times a whole number, you need to write the whole number as a fraction. So we have 3/8 times 40 over 1 plus 4/5 times 40 over 1 equals x over 20 times 40 over 1. And now we can reduce. 8 goes into 8 one time, and 8 goes into 45 times. So we have 3 times 5 is 15 over 1, which is 15. 5 goes into 48 times, and 5 goes into 5 one time. So we have 4 times 8 is 32 over 1, which is just 32. And 20 goes into 20 once and 40 twice. So we have 2x on the right side. Now we've cleared our fractions. All we have to do is add what's on the left. 32 plus 15 is 47. So 47 equals 2x, and we divide by 2, and we get that x equals 47 halves. Our next problem is very similar, but we have a variable in the denominator now. We need a least common denominator. 3x and x are common denominators, so that, both 3x and x go into 3x. So if we multiply everything by 3x, we will clear our fractions. Least common denominator equals 3x, and we rewrite 5 over 3x times 3x over 1. We have to multiply every term on both sides by 3x equals 1 times 3x. We don't have to write it as a fraction over there because we're multiplying by a whole number. Okay, let's start canceling. In the first fractions, we have 5 left. Second one, the x's canceled, so we have 9 left, and that equals 3x. 5 plus 9 is 14, equals 3x. So when we divide both sides by 3, x equals 14 thirds. In this problem, we have a simple comparison. 2 over x plus 1 equals 1 over x minus 2. You always need to find out what x is not allowed to be when you have an x in your denominator. So, for instance, over here, I didn't do that, but x cannot be 0 because it would make this fraction and this fraction undefined. We found that x isn't 0, so we're all right. But over here, we know that our denominators are not allowed to be 0. So x plus 1 cannot be 0. That means what would make x plus 1 0? Well, if we subtract 1 from both sides, we know that x equals negative 1. Negative 1 plus 1 equals 0, so x cannot equal negative 1. Also, x minus 2 equals 0. It can't equal 0, so x cannot equal positive 2. Then when we solve this, we need to compare to these answers to make sure our answers are valid. Okay, here we have a binomial x plus 1 and x minus 2. We need to find a least common denominator that x plus 1 goes into and x minus 2 goes into, and so we're going to just multiply them together, and our least common denominator is x plus 1, x minus 2.